Okay, welcome back. Let's go ahead and continue talking about circles and segments within the circles. Today we're going to talk about chords and using these chords and what that tells us about the measures of the arcs and things like that. So today we're going to look at what happens when a chord intersects a diameter and also what happens when chords are congruent to each other. Okay, so congruent corresponding chords theorem. Very, very simple. Okay, can read about it here or I can just tell you here. So if this chord is congruent to that chord in the same circle, that means that the arc they intersect, in this case arc AB and arc CD, are also going to be congruent. So if the segments, or excuse me, the chords inside the circle are congruent, their arcs are also going to be the same, which means, let's look at just a really simple example down here. And some things that we can remember that we know about arc measures and things like that. And the thing to remember here is the examples that we're going to do, they aren't related to each other, so don't use your answer from one of them to get an answer for the second one. So it says if the measure of arc PQ, so let's find that, is 130 degrees, so we know PQ, that would be this guy right here, arc PQ, and we know it's the minor arc because it is only going from P directly over to Q. If it would have been a major arc, we would have gone PRQ if it was talking about the bigger part. So it tells us that PQ is 130 degrees, okay? And we also know that these two pieces, this chord and this chord, are both 7. Which tells me if those two chords are congruent to each other, that means that this blue arc and this blue arc are going to be the same. So I have to think a little bit here. So I know I'm going all the way around the circle, so I know that if whatever the measure of this arc is going to be the same. And if I'm going all the way around the circle, I know that those things are going to be 360 degrees all the way around. So let's write an equation for that. So for question number 1, we can write it down here. Okay, that means I have both of those x's, both of those arcs, plus that other arc, 130 degrees, all the way around the circle would be 360. Which means I can put my x's together. I'd get 2x plus 130 equals 360. If I subtract 130 from both sides, I would get that 2x equals, what would that be? We would have 230. And if I divide both sides by 2, I would get that each of those arc measures is 115 degrees. So this arc would be 115 as well as this one. Okay, so think about that. I'm going to erase this so I have a little bit more room to work for question number 2. So let's go ahead here. I'm going to get rid of what I have here because it said right here in the red that questions are not related, so we don't want to use the answer for 1 to get any information about question number 2. So let's erase. Let me erase all of my stuff. And start with question 2. It says if the measure of arc PR, so in this case we're talking about arc PR, is equal to 100 degrees, so PR, that's this guy, that arc is 100 degrees. I also know then, since those segments are equal to each other, that this one is also 100 degrees. And it wants me to find arc PQ, which would be that part. So I know if I'm going all the way around the circle, I'm going to have 100 plus 100 plus whatever, I'm going to call it x, that red arc is going to be 360 degrees because all the way around the circle is 360, and we'd get 200 plus x equals 360. And if I subtract 200 from both sides, the measure of that arc up there is 160 degrees. So if the chords are congruent to each other, then the arc measures are the same as well. Okay, so let's just look at a couple of examples here. We have circle P and circle Q, and FG is congruent to JK, Okay, they aren't in the same circle. However, that's okay if they're not in the same circle, as long as we know that the circles are congruent because the radiuses, or the radii, are the same measure, and if the radii are the same, then the circles are congruent to each other. And we know that JK, that right there, is congruent to FG. Therefore, if JK is 80 degrees, that means that FG also would have to be 80 degrees. And we also could know that, just in case we were wondering, this is 80. If we wanted to know the rest of the arc in that circle there, we would just have to take 360 minus 80. Okay. All right, here we have another idea that we're going to look at, and this is when we have a chord that intersects with a diameter. Okay, so what we know, we can look up here, is if a diameter of a circle is perpendicular to a chord. So here we have our E8, or EG is our diameter there, and we have this chord, FD, we have this chord, okay. If they are perpendicular to each other, then the diameter bisects the chord and its arc, okay. So that means if they're perpendicular to each other, then we would have this part and this part would be congruent to each other, and then the arcs they intersect would also be congruent to each other. And it goes the other way too. All that the converse says is if one chord of a circle is perpendicular bisector of another, so if it bisects the chord and its arc, then it's a diameter. Okay, we're going to look probably more at it in the first scenario. So in other words, to put it simple, if a diameter and a chord are perpendicular, then the chord and its arcs are bisected. And remember, bisected means break into two equal pieces. All right, so let's look. Here we have, look at our diagram. I have a diameter, and I also have a chord. And look at that, they are perpendicular to each other, which means if they are perpendicular to each other, then the two pieces of the blue are going to be equal to each other. So if this is 7, this is also going to be 7. And we also know that these two are bisected and will be equal to each other. So what are we asked to find over here? We want to find HK. Well, HK is the segment. It's a chord, okay? It's not an arc. It's a segment going from H to K. It's a chord. And I already showed you kind of here a little bit. Since it's a diameter and a chord, it's bisected, so these two pieces are equal. So we'd have 7 and 7, which means HK is going to be 14. And then the measure of HK, okay? In order to find the measure of this arc here, okay, first we're going to have to figure out what X is, okay? So let's see. I know that they are equal to each other because I've got a diameter and a chord, and that arc is bisected, so that means that 11X is going to equal 70 plus X, okay? So if we subtract X from both sides, we get 10X equals 70, and X equals 7. Now 7 is not the measure of anything. 7 is just your value of X. Now we need to go back and put it into our expressions here. So if X is 7, that means this would be 77. And since they're equal to each other, this is also 77. So from H to K is 77 plus 77, which is going to be 154 degrees. Remember, when we're talking about the measure of arcs, we are talking about them in terms of degrees. Okay, let's keep moving on here. Let's just look at a couple of practice problems here. So what we have is the measure of arc AB is 110 degrees. So let's come over to our diagram and label that. That's 110, not 100, 110 degrees. Okay, And I know that those chords on the inside are congruent. This is 9 and this is 9, which tells me that arc BC is also going to be 110 degrees. And it wants us to find the measure of arc BC. Well, I just figured that out for us, right? So the measure of arc BC, since those chords are the same, arc BC is also going to be 110 degrees. If I know the measure of arc AC is 150 degrees, keeping in mind kind of like that other question, we don't use the information from one to answer the other. If the measure of arc AC is 150 degrees, the measure of arc AB, that's what we're trying to find. But the only way we can really find that is to find all the way around the circle. So we know that those two are the same. So I would have 2x plus 150 equals 360. If I subtract 150 from both sides, I would get that 2x is 110, and x is going to equal 55 degrees. Now, 55 degrees is the measure of arc AB. All right, let's do one more here. Find the measure of CE. All right, so that's from here to here. I know that I've got a chord and a diameter that are perpendicular, which tells me those are going to be the same. I'd have 5 and 5, which means CE is going to be 10. And then the measure of arc CE, this is just like an example that we did a little earlier. So since we've done one just like this, why don't you pause the video, try it on your own, and then check back, and you can see if you are correct or not. Okay, so we know that those two arcs are going to be equal, so we'd have 9x equals 80 minus x. X is 8, but we know that it's not asking what is x, it wants to know the measure of arc CE. So from C to E, that means we would have CD is 72, DE is also 72, we just add them together to get 144. Okay, so another one where we have two chords. If you have, in the same circle, two chords that are congruent, then they're the same distance from the circle. So two congruent chords are equidistant from the center of the circle. Okay, doesn't have to be a diameter, doesn't have to be anything like that. If you just have two chords that are congruent to each other, then they are going to be the same distance from the center of the circle. Okay, so let's go ahead and use that idea. If we know we have two chords that are congruent, we have QR here, and we have ST, and they're congruent. We know that because it tells us that up here. And we know that they are 16. Okay, so if we have two chords that are congruent to each other in the same circle, then that means they're equidistant from the center, which means I know that 2x and 5x minus 9, that's the distance from the center to the chord, are going to be equal to each other. So I'm going to know that 2x equals 5x minus 9. And then if I solve for x, I'm going to subtract 5x from both sides. I get negative 3x equals negative 9. So x equals 3. Okay, that's lovely. However, that doesn't answer the question. It's asking us to find the radius. But what I can do, this is going to be multi-step here. I do know that that's 2x, which I know that that distance then is going to be 2 times 3, because that distance, because I know that x equals 3. So I know that this is equal to 6, because 2 times 3, because x equals 3, is 6. Okay, so I know that this red, I'm actually going to make that into red, because that's what the segment is. This red, I wanted to make it red, is 6. Okay, so this length right here is 6. Okay, what it's asking us to find is the length of the radius. Well, the radius goes from the center to the outside of the circle. So if I want to figure out the radius, I want to make my center out to one of the edges of my chord. Okay, so I have this right triangle here that I'll make green. I have this right triangle that I am looking at. Okay, I know that this side of the right triangle is 6. I can figure out this side of my triangle because I know that QR, the whole thing, is equal to 16. It tells me that in the directions, okay? And I also know that I've got a chord and a diameter that are perpendicular to each other. So I know that that chord is bisected. So I know that this part is half of 16 because the whole chord is 16, which means this part is going to be 8. So let's pull that out here just a little bit, like look at what that triangle actually looks like. I'm just pulling out that triangle I just was looking at. Here's my right angle, here's 6, and here's 8. And here is my radius that I need to find. Well, if I have a right triangle and I want to find basically the hypotenuse, I can use the Pythagorean theorem. So I can say 6 squared plus 8 squared equals r squared. And 6 squared plus, so I'd have 36 plus 64 is r squared. I'd have 100 equals r squared. So r equals 10. So the radius of my circle is 10. All right, let's look at one more of those just to make sure that we knew what we were doing here. This is the exact same idea what I just did on the last one, so I want you to look at the question. I would like for you to read through it, find what right triangle you want to draw in there, what values you can find, what you know, and see if you can find what the radius is on your own. So pause the video. Please figure it out if you can. If you have questions, please ask. I'm also going to put the answer here so you can kind of see it in just a minute, but I'd really like you to try it on your own first. Okay, so just like last time, I've got my red line and my blue line are going to be equidistant from the center. So I know that 3x equals 7x minus 12. If I solve for x, I get negative 4x equals negative 12, x equals 3. That tells me that I know that if x equals 3, oops, daisies, then the length of that red segment is going to be 3 times 3. Okay, so I know that this length right here is 3 times 3, which is 9. And I also know that JK, the whole chord there, is equal to 24, which means that since I have a diameter and a chord, it's going to break into 12 and 12. And I'm going to have my radius going from the center to the edge of the circle, and that's going to be the hypotenuse of my triangle. So if we pull that triangle out, it's going to be like this, kind of. I would have, here's my right angle, here's my radius, 9 and 12. It doesn't look exactly the same. So I have 9 squared plus 12 squared equals r squared. I'm going to have 81 plus 144, which is 225. Got to take the square root. So my radius is going to equal 15. If you have questions on that, please let me know. Please ask. Otherwise, when you finish up, you have a class kick assignment to work on.